I guess I could be talking. I was talking to the camera. Oh, you're good. It doesn't matter. That's called leverage. So this white stuff is going to be the epoxy they put on the threads to keep it from coming apart. Just clear that out. This is the unit actually. And what we're going to do is we're going to remove this chip right here on the back of this motor, and we're going to put an RCA in. So all you have to really do, basically what's happening here, and I'll explain this out, is Cheyenne, these motors run on DC power, direct current. But Cheyenne, in an effort to keep you using their stuff, put this little bit of circuitry between it. So that's why you need their power supply, their PU unit. Basically, it sends a sine wave, alternating current basically, out to this, and this turns it into a DC current. So really, you don't even need this. This motor runs on DC power. This is just kind of a middleman step to keep you using their stuff and requiring their power supplies and products. So we're just going to take that off, and then we'll start getting it put back together. Although I might real quick look at a different cap for this back here before we go forward. But that is so far RCA conversion process on a Cheyenne Spirit, which would be pretty much the same for the Thunder and the original. So, all right, I'm gonna pause it right here and consider a back cap for that before I move forward. All right, we're gonna de-chip this motor, and I'm gonna show you how to do that. These work really well. They came with my Ender 3 printer. These little dikes, these little cutter dikes, they have worked well for everything other than 3D printing. I mean, they probably work great for that, but I have used them for everything else. So, but you want to get you some kind of like some kind of cutters with a fine point. I got these dikes, but they're pretty broad up here. I don't like to use those. They're not as sharp. So that's what I'm gonna be using. So anyways, long story short, you have this. Let's identify everything. So if your machine's like this, you got this wire, or basically this solder point and this solder point, and they're both pretty big. You're gonna see them. There's also one up here, but this is just a ground. This is irrelevant, and you know it's the ground because it goes to the outside body of the motor and not to a terminal that runs it. So first off, we can start by just I'm doing this to a camera that clipped really easily. Okay, I didn't think that was done. Wow. Now if you want to save this chip for some odd reason, you can probably cut down the side of this pin. You got a straight pin coming back here. It's kind of got a flat face. You can cut the solder off the side and then cut it up under, or you can just cut this thing straight off like that and solder to the little points underneath it. I don't know if you can see that. I'm actually going to clip to the side and try and spare the chip so I can give it back, so they'll have the original parts. So I'm going to do this a little bit lower, I guess, and try and keep it in camera's view. So. I'm kind of wobbling. I'm sorry. I'm not gonna lie, you can also probably heat this up with a soldering iron and it'll slide right up. I'm being lazy. It might have to do that. Damn, this one's, they put a lot of extra solder on these newer ones. The older models, they looked a little different. They didn't have the, well, I don't have to explain it to any tattoo artist. They've seen it. Yeah. I am going to clip this down a little bit. I don't need that much to solder to. I think it's got the best of me. So it looks like I will be using a soldering iron to heat these pads up and melt the solder and then remove the piece. So sometimes it happens that way. All right. So I'm gonna use this as a pry. I'm gonna just set it up under there. We're going to take this, see if I can do this in the air. Probably not. Nope, sorry, you guys just going to have to guess. This is as good as it gets. Can't figure it out from here. Might not ought to be doing it. Chaser. Oh. Look at that show going on. Oh well. Can't win for losing. Open the windows. So this is what the back of the motor looks like. Matter of fact, you can go ahead and get the number for the motor. And from the looks of it, let's see. This is going to be your positive terminal. This is going to be your negative terminal. How do we know that? It's obvious. Let's denote it right here. Positive terminal. Although I don't see a negative on the other side, but that's irrelevant. Once you have the positive identified. Glue. Put something on. Anyways. So that's how it goes. You got two terminals. And again, these are for DC power, direct current, which your power supply and whatnot is going to put out. So, all right, that's it for right at this second. Took the wire off here, off this chip in here, this, and I'm just going to use it with an RCA on this. So I'm not really worried about which one of these is going to positive or negative, because once I put it on there, then whichever one is on positive or negative, whether this white wire line or the fully black. Actually, I probably will put the white line on the positive. But either way, it doesn't matter. If you solder this on first, it doesn't matter. When you solder your RCA on, make sure, let's do it this way, that this is a fucked up one, that the center post of the RCA, that's the positive, and the outside's gonna be the ground. So make sure the center wire goes to the positive. So just note that. But I'm gonna solder this on real quick. Okay, so went ahead and soldered. Put this cap back on, and then had the wires hanging out, and then soldered them to this. I kind of explained which ones went to what earlier. The only problem was the threading on the back of this RCA cable or connection did not fit the internal diameter of what the old 3.5 used to be. So, a little trick, I took some quick epoxy and the quick set, it's like five minute setup time, and mixed it up, let it set for a little minute or two, and then put it on here and kind of like, just kind of spun it around to where once it enveloped it, it kind of like, the spinning kind of centrifugally, you know, evened it out, you know, just like just doing that a bunch, flipping around so it didn't droop to one side or droop to another, just kept it going, and it was almost set up by the time I put it on there. So now that we got this a lot bigger, we're gonna put it in there and we'll put those screws in to hold it. And I might have to push hard because I might want to lock up right there. So we're going to push this down as hard as we can. It's going to stop at some point. And then we'll go in. And we'll try and tighten these screws up on whatever is there. And going around and doing a little bit on each one, not just all of it on one, is ideal. It's hard to do this looking through the camera, so I am moving it out of the way. If you can't tell that I'm just, this is what I'm doing. I lost you somewhere along the line. I don't know if there's hope. Real quick test. Yeah, this is my little junk one. I just use it for testing stuff. That's it. That's the winner. Let's see. Ooh. I guess that took a little while. Anyways, me and the gentleman I'm doing this for already discussed the potential that this would not be able to be used. It's not like the old ones. You got too much distance here, and otherwise you're building a big spacer, and then the battery pack's getting even further off. Or so we talked about just leaving this undone like that, and maybe making a cap that goes over it, just a short one. So that's basically it, though.